Hi everyone, my name is Matt Dozier with the U.S. Department of Energy. We're here in Denver, Colorado for Solar Decathlon 2017. If you've been watching any of our streams so far, you know that this is a competition that challenges student teams from around the world to design and build solar-powered houses. The solar-powered house we are in front of right now is the Crete house by the Washington University and St. Louis team. So we're going to go inside, meet some of the students, and see what makes this house so special. So follow me. We'll walk along the front of Crete House. We're here in Denver, Colorado on a beautiful, bright, sunshiny day. This competition is a 2-year competition, and teams have been working really hard to build and design these houses, break them down, and ship them here to Denver, rebuild them for the competition, which goes through October 15th. So, without further ado, I'd like to introduce you to one of the students with Washington University in St. Louis. What's your name?
My name is Adam Goldberg. Hello, Facebook.
Nice to meet you, Adam. Why don't you tell us a little bit about this house?
I would love to. So, this is the WashU St. Louis Crete House. The word Crete comes from concrete. We are incredibly unique in the fact that we're not just the only precast concrete house in the competition currently. We're also the second or third in competition history, and according to the organizers, we're the first to do it successfully.
That's terrific. It must be a nice distinction.
It's incredibly distinct, and it's a wonderful feeling.
Okay, so tell me a little bit about why you chose this particular building material.
So people ask me all the time. We didn't choose it just for the fun of it or for the design aspects. Instead, we chose it for resiliency. Resiliency in the sense of longevity, of building life. This will last significantly longer than your typical wood frame or masonry construction. And additionally, Missouri has the issue of tornadoes. But it's not just this is not just meant for Missouri and tornadoes. It's also meant for be able to transport this to places like Puerto Rico or to the Gulf Coast, where it's become all too apparent in recent months that this is more useful than ever, more important than ever for a sense of mind, peace of mind, and safety for the individuals that live in it.
Absolutely. So why don't we head inside and see what you've got in store in terms of the innovations that this house has to offer.
Absolutely.
All right. So if you're just joining us, again, we're here at Solar Decathlon 2017 in Denver, Colorado. This is a competition where students from around the world have designed and built their own solar-powered houses. It's a really fantastic competition. As you can see, it's open to the public. We have people coming through. You guys are giving tours all day long, right?
Yeah, nonstop. When we opened up on Wednesday, actually, to 2,000 middle schoolers, local middle schoolers, and then another 2,000 on Thursday. And it's not just them. Families coming out all weekend has been incredible. Actually, some of the best questions that have even started to stump me have been coming from 10-year-olds. It's unbelievable.
Sure. I believe it.
Yeah.
So let's talk a little bit before we move inside. These, very eye-catching columns here. What is the function and the form of these?
Absolutely. So these so-called columns are actually our precast concrete gutters. So our quote-unquote flat roof is actually drained using tapered insulation above our main white foam insulation, and it's tapered to drain to all 6 of these exterior gutters. So instead of your typical aluminum gutters running around the house, we're able to shoot this down to the 6 different spots, down the vertical elements, and into collection basins. So what that does is those collectors send water back to our rainwater storage tanks and can feed back from pumps into the irrigation system that runs up the vertical gardens as well.
All right. So what kind of stuff are you growing in these gardens here?
So for the competition, we picked enough herbs and vegetables to last us until next year. In fact, I'm sure during the cooking competition coming up on Tuesday, Wednesday, that people might be coming over to us and say, hey, can we get some rosemary?
Yeah.
And the answer will be yes, because we have more than enough.
That's good. So you guys will be part of the team spirit here in the Solar Village. Yeah. You'll be able to lend a neighbor some pinch of herbs.
Yeah, absolutely.
Okay, cool. So is there anything else on the deck you want to show us, or should we move inside?
There's something actually right behind you that's quite worth noting. So this past semester, during one of our own faculty members led a furniture design class, and this is the result of it. It's a really beautiful glass fiber reinforced concrete and bamboo with aluminum straps for the structure of it. And we built a number of these and brought them out here, and we absolutely love them. The public loves them, young and old. It's really fun seeing people come out the bedroom door there, where my classmate Percy is, and we can have people just enjoying the sun out here.
Yeah, it looks great. I mean, very comfortable. So you said that's actually concrete. Yep. Integrated with the furniture?
Yeah. That studio was, again, led by a faculty member that's also part of this project. So and keeping the theme of concrete going as much as possible, which you'll see a lot more in the interior as well in some pretty unexpected places. We wanted to keep it going.
All right, terrific. Crete House, living up to its name. Let's follow our winding path here and see what else you guys have to offer.
Yeah, I'd love to talk about the path, actually.
Sure.
That was always such an integral part of our design. Being someone who cares a lot about accessibility and in the built environment, it's unfortunate to see sometimes when ramps are treated or accessibility in general is treated as an afterthought. So for us, we took full advantage and made it a really integrated part of our project. So we have this really nice meandering path that walks you through the whole garden as well as takes you on a route through all of our signage so that people can really get a sense of the project and get inside, and they're already experts on it. They can really just enjoy it.
Great. So the tour is doing, the path is doing your work for you.
Exactly.
Okay. I see a sign about the photovoltaic system. So you want to tell us a little bit about the solar panels that are powering this house?
Yeah. So pretty much our entire 1,000 square foot roof is covered in solar panels. We produce significantly more energy than when we take in, than what we need, and that's all due to our successful passive design strategies. Our insulated sandwich panels for the concrete really take off a huge burden in the energy loads for our mechanical systems, and as a result, we were able to put back to the grid and also put back to our Tesla battery pack, which is wonderful to have.
Yeah, terrific. Okay, cool. Again, this is the Crete House by the Washington University in St. Louis team here at Solar Decathlon 2017. If you're watching live on the stream, please send in your comments, questions. We'd love to be able to answer them. Tell us where you're from if you're watching live. If you have questions and we don't get to them during the stream, we'll try and answer them afterwards. Again, so this is the Washington University in St. Louis Crete House. So what do we got next?
Well, next we can take you right inside for the fun part.
Sounds great. I don't know, this has been pretty fun so far, so it's got a lot to live up to.
You won't be disappointed.
Okay, in we go.
As always, it's been rather busy in here. The public's been really enjoying this. There's a real aura of positivity when they come into this house. They're always blown away when you walk in to see all the exposed concrete. Again, this is something we're celebrating. We're not trying to hide it. The few people that don't love our walls are talking about painting it. Like, no, that's not the point of this. We wanted to continue the theme of concrete as much as possible and really enjoy it. And overall, the public absolutely loves the finish of our walls as well.
Yeah, it's
everything.
Yeah, it's very nice looking. So yeah, we can see if you're watching the stream, you can see a lot of unfinished concrete, but very nice looking, very elegant. I think we can agree it's a nice looking space.
Thank you.
So talk a little bit more about the design philosophy, of the kitchen and this whole area here.
Yeah, so you can essentially break this up into three different sections, three different zones. So you have the main public living quarters here. You got your kitchen with a beautiful island. We have precast concrete countertops with this beautiful waterfall edge too. Recycled glass aggregate. People come in here and they say, "Oh, I thought you wanted concrete everywhere. Why do you have granite countertops?" I say, "No, this is concrete," and they're always blown away. And people are like, "Oh, well, I think it's time for me to put this in my kitchen too." So it's fun hearing things like that.
Absolutely. Okay. Pretty busy in here. Should we move on to next room? Okay. See if we can escape the crowds for a moment. So you guys have been pretty busy, you said, slammed the whole way through?
We have been. For the last week and a half, it's been nonstop. First construction with our 10 semi-truck showing up on site, our 50-ton crane coming in and placing this thing and bolting it all together. The whole enclosure goes up in only 3 days, and from the rest of that, it's all just finish work, which we feel it did a wonderful job with. What you can see inside, when I mentioned these three different zones, the second of which is this largely 13 by 13 concrete clad box. This is not drywall covering this. Again, this idea of resiliency for us. Instead of drywall that would soak up water and moisture and mold, we have a high-performance concrete material called Tactile that is going to resist all of those things. It's incredibly strong, and it's just a fun way to bring concrete into the exterior, into the interior a little bit more.
So this is. Oh, we have a question. Okay.
Question from St. Louis.
Hey.
From St. Louis. All right.
Ethan asks, could you tell us about the concrete on the outside of the house? It's a pretty sweet pattern.
Ethan wants to know about the concrete on the outside of the house. If you couldn't hear that question.
Ethan, that's a wonderful question, and I realized when we walked inside that I grazed over that detail. So we have this sandwich panel, the structural layer on the inside, but the outside is this material called ductile. It's a super high-performance concrete, And what that allows us to do is with just an inch to an inch and a half of this finish layer, we're able to, back in the spring, designed and built our own molds, our own formwork for this exterior layer. And because of that, we get this incredibly sharp edge and this beautiful shadow line that happens throughout the day, but especially early in the morning and then in the evening as well.
Awesome. Okay. Thanks, Ethan. Yeah. Great. So you were talking about this, and so it sounds like this is sort of extra reinforcement. Is that what I'm understanding? I gather that this you mentioned tornadoes earlier. This house is extremely resilient, but also resistant to storms, right?
Correct. Yeah. As I mentioned, this is something that can be placed in Missouri as well as the Gulf Coast. This interior finish, it doesn't need to be there, but because the entire box of the entire enclosure of the house is resilient to storms. Our window manufacturer and door manufacturer back in St. Louis actually specializes in making bulletproof and stormproof systems for things like embassies and hospitals. So if we wanted to specify those systems for these windows, this place is a bomb shelter / storm shelter without having to worry about going into your bathroom. You can go about your day. You don't have to worry about it.
Great. Okay. Did you want to touch on anything in the bathroom, or should we keep moving this direction?
Peek our heads into the bathroom. I'm pretty proud of it. So the first thing you'll probably notice in here is that it's the one place we have a drop ceiling. So what we're able to do is this 13 by 13 cube I mentioned, we call it the core because it houses our one plumbing wall, it houses our mechanical closet on the other side of the shower. It houses, up above us, we have our mechanical trunk lines and everything to supply ventilation, heating, and cooling for the house. But what's neat is that actually that HVAC system rarely has to run other than for ventilation purposes, because the floors have radiant heating tubes in them, and then we have radiantly cooled ceiling slabs as well to just maintain temperature throughout the day, regardless of the temperature outside.
Okay, so kind of all the guts of the house are sort of contained here in this area, right?
Yeah, this is the guts of the house.
Okay, cool.
Into the bedroom.
All right, bedroom time. Let's go. So if you're just joining us, again, we're here at Solar Decathlon 2017, touring the University of Washington, St. Louis. Crete house. This is one of the many houses here at Solar Decathlon. It's a village that is full of student-built houses, designed and built to use solar power and to generate more power usually than they consume. So if you're watching, please send in your questions. Love to hear from you. Now we're in the bedroom, so let's hear what's going on in this room.
Yeah, so something I don't believe I touched on yet is the user. That's a very important part of our project. This is rather untraditional. It's not going to be for a family. We don't have a master bed and a secondary bedroom layout. Instead, we have two symmetrical bedrooms split by this felt-clad partition wall, complete with a pocket door that when this thing closes up, you have two symmetrical bedrooms that are for two researchers. When this comes back to St. Louis, it will live permanently at a 2,000-acre outdoor research facility. And that's just the start of it. This will be the first of many homes in a new living building community out at this research center.
That's terrific. So what kind of research are we talking about?
So it's a 2,000-acre field operation owned by the university. So they do tons of ecological research outside. It's incredibly extensive forest research and other things with biodiversity as well.
That's cool. When did you make that decision, or when was that decision made about what the use was going to be?
That was well over a year ago. Once we got this project rolling and realized it was going to be a real project, the university jumped on it as fast as they could and realized that we can really use this for ourselves instead of giving this off to somebody else.
Cool. I'm sure they're very proud. We have another question?
One question from Shelby. How do you replace or repair pipes or electrical inside the walls?
Okay, Shelby wants to know how you replace or repair pipes inside the walls.
Repair pipes or electrical.
Yeah, so all of our electrical is precast into the walls during the pouring process. So we run all of our conduit in advance. And as a result, since it's sitting in a 4-inch layer of structural concrete, the chances of that getting damaged or needing to be replaced is next to zero. Everything else, we have outlets and switches that are actually in our core wall as well. So that you can treat almost more like a drywall, and you can cut into that and replace things if need be. That's where most of our important electrical equipment is anyways.
Okay, terrific. Thanks, Shelby. Shall we continue on now?
Continue on.
All right.
All of our bedroom closets.
Okay.
This north bedroom, unlike the south bedroom, which has its own private balcony, this one has a door that opens out onto the entire rear deck.
venture out. It's such a nice day outside. Hate to waste the beautiful weather.
Yeah, this is a really nice space back here. We have a really extensive decking system. It's actually almost 20% more exterior space than we do interior, and it's a nice place to be. We created all these actual bench and platforms back here in order to house our water tanks.
Okay.
We actually use a composite decking system. This stuff's incredibly durable, incredibly weather resistant, and instead of using a typical wood frame construction underneath the deck, we have a system called deck span, which is an extruded aluminum system that all screws together into these modules, and it makes shipping a lot easier and also makes it a heck of a lot more durable.
Okay, cool. So, and you've talked about the resilience of this. I would assume that there are probably members of your team who've had kind of firsthand experiences with storms, tornadoes, hurricanes, that sort of thing. I mean, was that something that kind of helped influence the team's direction, philosophy?
Yeah, I don't know if that was really something in our forethoughts here, and something that we were consciously thinking of from the get-go. But as these things happen, it makes it all that much more difficult to ignore. I mean, we have teammates from South Florida who saw devastation there just recently, and it makes it all that much more pertinent too, and it actually makes it all that much more important to us as individuals too.
Absolutely.
Kind of segues into another question from Lindsay. Is this a viable way to build houses? Should this be used in hurricane-prone areas?
Okay, is this a viable way to build houses? Should it be used in hurricane-prone areas? A question from Lindsay.
It's massively viable. In fact, if this thing were to become mass-produced and be actually modularized and into maybe a number of different selected floor plans that you can kind of pick and choose from, like a number of companies have already done, one, that takes away a huge amount of cost, and this thing, if that were to happen, would only be about $5 more a square foot than your typical wood frame construction. So you can drop something like this in a hurricane-prone area, and you are good to go, without a doubt.
All right. And another question. All right, great.
So what if, this is from Dennis, so if a water pipe breaks, are repairs the same as drywall structures?
Okay, if a water pipe breaks, are the repairs the same as drywall structures?
Yeah, well, actually, those panels that I mentioned, those tactile panels, are all just screwed onto the wall, so you're able to pop those off and have access to everything you need, because all the interior plumbing, all the domestic plumbing is behind that.
Great, which is even easier then. Right?
Yeah, absolutely.
Okay, cool. All right, so we're out on this back deck of the Crete house built by students from Washington University in St. Louis. Anything else you want to show us out here?
Yeah, I can show you our rather unique exterior Venetian blind system.
Sounds great.
People gotta keep asking us about these because they're quite unique. This is a German manufacturer called Hella, and they provided these blinds to us. They are largely just a robust exterior Venetian blind. They're aluminum. They are not technically storm shutters, but as I mentioned, we're able to specify storm-resistant glass, so it's not a necessary requirement for that. But what it does do is it creates an external shading device. What people don't understand is if you stick blinds on the inside of a window, once that sun is through that glass, you're heating up your house. You have to stop it from the outside, so that's what this does.
Oh, very interesting. Okay, so that's even helping your energy efficiency through shading it from the outside rather than the inside.
Absolutely.
Very cool. Okay, so where to next?
Back in through the north bedroom, and we can walk past the mechanical closet and back into the living room.
Great, let's do that. Okay, lead the way.
Sure.
Going back inside. Oh, we found the crowds. Everybody wants to know about the mechanical
I
closet.
had a team Switzerland.
I see.
Hi, guys.
The Swiss team is infiltrating. Okay. Well, let's see if we can squeeze by here. All right, so we made it. Here we are.
Sure.
Okay.
Hi,
What's your name?
My name's Melinda. I'm a mechanical engineering student. I'm a senior and a master's student at WashU. So welcome to our mechanical closet. Here we have our heat pump. So our heat pump heats or cools our radiant tubing. So we've got radiant tubing all through the concrete floor. So those are placed before the concrete is poured. So those are these white tubes that you see coming out of there. So they kind of zigzag across the floor and across the ceiling, and we run hot water through the floors to heat in the winter. We run cold water through the ceilings to cool during the summer. And so that's powered by this heat pump, water-to-water heat pump. So right now it's hooked up to an 1,100-gallon tank in the back. But when we get back to Tyson Research Center out in St. Louis, we'll have a ground source heat pump. So then we've got this guy up here, and this guy will provide any extra heating or cooling that we need, but also mostly just for ventilation purposes. So even though we're doing our heating and cooling through radiation, we do need to provide some amount of fresh air, and so that's what the ductwork is for. And it is also sized to be able to handle the full heating and cooling capacity if needed in a quicker amount of time.
Terrific. So this is, very flexible. It's able, whatever the climate, it can keep you warm, cool, whatever you need, and it's, you've got all the hardware here you need for that, right?
Yeah, absolutely. And another thing that helps a lot, even whatever the climate is the thermal mass of the concrete. So it just takes a really, really long time for heat to move in or out of the concrete. So you don't have to spend that much energy on heating and cooling because your house will hold that heat or hold the cool for you.
Right. Okay. So, and I want to come back to this again. You guys are all about the concrete. Like, how did that happen? What made you decide, oh, these other building materials are for suckers? We're going concrete all the time.
So I can answer that. So this all started due to a couple of relationships from some of our faculty members with the Precast Concrete Institute. PCI sponsors a number of academic ventures throughout the course of this school year, and ours is one of them. Our architecture studio was sponsored by them, and thanks to them, we were able to get all the industry members together and create something that was feasible, and the industry support was absolutely incredible.
Very cool. Okay. Well, thank you so much for the tour of the mechanicals and the rest of the house. Let's see. We can step back over here. Can we jump back out on the patio real quick?
Now we got a pretty good shot of a busy living room. The one thing that people seem to love here is, in addition to the piece of furniture outside, we also had a student and faculty-led 3D printed coffee table, which is down here. Everyone really seems to love that.
Oh, very nice. Okay. That's very cool. So this is lots of different students, faculty, all contributing to this project. Sounds like a real team effort.
Yep, absolutely.
Okay, cool. Think we can jump back out here just to sign off. So this has been the Washington University in St. Louis Crete House here at Solar Decathlon 2017. Adam, thank you so much for the tour.
It's been a real pleasure. Thanks, Facebook.
All right. Thanks. One more question.
This is a good one.
Okay.
Yes. I love that. This is from Shelby again. Love the house in the mountains of Utah. There's always the danger of forest fire. This would be great for that. How do I get more information on this house?
Okay. Question about forest fire and how this house, could play a role.
Yeah. Well, luckily, concrete and this whole house is completely non-combustible. So after the smoke clears, you can essentially just take a power washer to this thing and bring it back to new. Right away. It's a wonderful thing for so many different natural disasters, and you can find out more on the DOE website, the Solar Decathlon website, and WashU as well.
All right, great. Thanks again.
Thank you.
So this has been another Facebook Live broadcast from Solar Decathlon 2017. Matt Dozier with the U.S. Department of Energy. Thank you so much for watching. We're really excited to bring you all these houses in this incredible solar village. If you want to vote in the People's Choice poll, you can go to the Solar Decathlon Facebook page and vote for
the WashU Crete House.
WashU Crete House. Okay, well, thanks, everybody. We'll see you on the next broadcast.